Hi, this is an example of Coulombs law off the lecture slides. This is example 2. The question is, will the -2 charge move toward or away the other charges? And what's the magnitude of the force of this charge? So let's take a look here. We have a negative charge, positive charge, negative charge. And the question is, what's going to happen here? So just kind of speaking conceptually here, this being a negative charge, this is going to be drawn toward this, but pushed away. So the question is, what's going to happen? Is this going to be pushed away or drawn toward? And how big is that value? So that's what we're going to calculate in this problem. So the first step, as I always do, is, if I can do my steps here, is, analyze the direction here of the forces for each charge. And as always, I like to label my charges. So this is Q1, Q2, and this is Q3 like this, okay? So here we go. So the force, I'll do this in blue. The force on Q1 from Q2 is going to be toward, because this thing is negative, this thing is positive, and they're going to attract each other. So this is the force of 2 onto 1, and that's the way we write it, force of 2 onto 1. So this thing's going to be pulled this way, and that's what I'm doing, I'm analyzing the force, because this is going to give me direction. Now for this one, we have a negative charge. So this one is going to push it forward. So, and the reason why, or I'm sorry, I should say push it away, because this is negative and this is negative. So this one's going to push it like this. So this is a force of 3 onto 1, just like that. And the question is, which one's bigger, which one will win? So the next step, after I figure out the direction of each of these forces, I'm going to find the strength of each force. So just the strength. And again, when I find the strength, I don't consider signs. I just want to know how big. So I want just the magnitude. That's the name of it. The magnitude means just the strength. So the force of 2 onto 1 would be K Q2 Q1 over the distance between the two charges squared. Call it 2, 1 for the distance between. So K is a 8.99 times 10 to the 9th Newton meter squared over Coulomb squared. So anytime you see the Q here and they don't give you any other piece of information, you assume Q is the charge, which is 1.6 times 10 to negative 19, or capital Q. So you can make this assumption, like I said, anytime they don't give you any other values. So with that said, this is going to be 2 times 1.6. This is for Q2. So actually, let's go ahead and write it the right way here. This is 3 times 1.6 times 10 to negative 19 coulombs here. And this one's 2. So I'm just, taking it and multiplying it, and I just did it in one step here. Now, another thing I wanted to point out, too, is notice that I didn't put the negative for the -2 here. I just want the strength. I don't want the direction. I'm going to do the direction later. Now the distance is going to be 4 meters squared between the two of them, because that's how far apart they are. Now this one's really obvious, because that's literally labeled right here, but when it becomes more difficult is when they don't actually give you this value. You have to use either geometry or some logic to figure it out. But this one, it's 4 meters. That's kind of nice. So what I'm going to kind of do is put this into my calculator. So here I am going ahead to do that. 8.99 to the 9th times 3 times that number, 6 to the negative 19th, times 2 times 1.6 e to the negative 19th, divided by 4 squared. So I get a pretty small number when I do that, naturally, because I have to the negative 19th for both of these. So I get 8.99 0.63 times 10 to negative 29 newtons. This is pretty much 0 at this point, but that's okay. So let's do the same thing. I'm still on step 2, finding the strength. I'm going to basically rinse and repeat here with the same thing, KQ3, Q1 over R1, 31 squared. I'm going to go ahead and do this. This is our K right here. And then we're going to do 4 times 1.6 times 10 to negative 19. That's a times. I don't know why I did times here and that, but this is the same thing. Okay, the same first charge. I guess I'll be consistent here. Just like that. Now we need the distance separated. So you might jump to this right away because it's a number they give you, but that's not what you want. You want the distance from here to here. That's how far apart Q1 and Q3 are. So that makes it 11. So we're going to do 11 here and then square it. So let's go ahead and type these in. I'm typing in the charges. Oops, 2 times 1.6 e to the negative 19th. All of this divided by 11 squared, 1.52. And there you go. So now that I found the strength, now I'm going to find the direction and add signs. So this is when we make things positive or negative. So I hope you can see that visually here, this one's going to the right, this one's going to the left. This one will be positive and this one will be negative. Now notice in this problem I didn't go ahead and do x and y's and all that fun stuff because we're only in one direction. Since there's no up or down or angles, I don't need to consider x and y. So I can simplify my problem just by considering the one direction and then adding my signs. So this one's positive because it's to the right and this one will be negative because it's to the left. So this becomes the net force. Coulombs law is basically we're having a tug of war. And this one's a bigger number, so basically we're going to get pulled by this more than that. That's going to cancel some of this, but it's not going to dominate. So what we get is the net force is going to be the sum of these two. So the right force minus the left force. So the right force minus the left force. I'm going to go ahead and do that. Oops, I forgot my 2 here. This is 5/2. Let's just squeeze that in, 5/2. And my final answer, 7.11 times 10 to negative 29. Since the answer is positive, it's to the right, but I'm going to go ahead and just write it in here. Just like that. So our prediction will be, well, the answer is to the right. That's because this number is bigger, and particularly because it's closer. So the smaller this number is, the bigger this becomes. So even though this is a bigger charge, the fact that this is closer is a more influential part of our force here. So in the end, 7.11 to negative 29 to the right. And that's our net force there.